How are you guys? Welcome back to thinktankonlinelearning. So in this video, we're going to be looking on Fourier Series. Okay, so this is one of my video in the playlist of Fourier Series. If you're looking for other videos like this one, check in the description. You're going to see a playlist named Fourier Series, Fourier Transform. You're going to click there, you're going to find other videos. So in this video, I'm going to explain you how Fourier Series works, and I'm going to illustrate using an example. And I'm also going to talk about even functions. I'm also going to talk about odd functions. Okay, so I want to evaluate the Fourier series of the modulus of t, right? In some questions, you may be given that this is f of x equals to mod x. It's just the same, okay? But in this case, our variable is t. Okay, so this is the formula for the Fourier series of functions. A naught over 2 plus the summation of a n cos n pi t over L. So if a variable is x, remember whenever there's t, that is going to be x, okay, plus bn. And now for the Fourier series coefficients, we have a naught. So a naught is 1 over L, then from negative L, ft dt. But in some books, you're going to see that they may write 1 over 2L. So if you write 1 over 2L, that means right here, you're going to only have a naught. Okay, so the difference is here. You put 2 over 2 here, there's no need for putting over 2 right here, okay? And for a n, it's 1 over L, negative L to L, ft cos n t over L. Okay, then for bn, 1 over L, negative L to L, ft sine n pi t over L dt. Okay, so what you're going to do before starting to evaluate those Fourier series, let's start by sketching what we have. Okay, so now what I'm going to do, I'm going to sketch this graph over the range from negative pi to positive pi. Okay, so I'm going to write my f of x right here. Okay, and the range is going to range from negative pi to pi. So from negative pi here, of course, I'm going to pass through 0. I'm going to have from positive pi here. And I'm assuming that everyone knows how to sketch this graph, because I think if you are starting Fourier series, that means you've done a lot of mathematics, like sketching the graph, okay, just like that. So I'm going to assume that you are familiar with sketching graphs. Okay, so this is going to be the graph for the modulus of x, and I'm going to have a graph on this side again. Okay, so what does mod of x mean? Okay, so now we can agree that if the graph is f of x is equals to modulus of x, okay, but in this case it's t, right? I'm just using x just in case you may be asked a question with x. Okay, so this is same as saying f of t is going to be, what its modulus is from negative t and positive t. So it's going to be negative t here and positive t here. Okay, so now this is just a set. So what is the range of negative t? You can see from negative pi to 0. That's where t is negative. Then on positive, it's from pi. It's from 0 to pi. From 0 to pi, right? From 0 to pi, you can write equal to here. Okay, so that is the range. Okay, so now this is the region that we're going to sketch. Okay, so what I'm going to do, I have to calculate a naught, a n, and bn. Okay, so before I say something that I want to say, let me start by calculating a naught. Okay, so a naught, we said it's 1 over L. And what is L? We can agree that we have two functions here, negative t and positive t, right? So it's going to be 1 over pi from negative pi, right here, to 0 of the first graph. What is the first graph? Which is going to be the first function, which is negative t, right? ft here. And I'm going to write dt, plus, we're not forgetting the other half, 1 over pi from negative L to positive L. So it's from 0 to pi of, this one is now positive t dt. Okay, and now what we're going to do, if we integrate, okay, so but there's something that you may need to know. Okay, so this is just a simple mathematics, it's a simple integration. The region from here to here is just the same. So that means if I just calculate the region from negative pi to pi, I can just say that region times 2. But it's symmetrical, as you can see. It's symmetrical along the y-axis. Okay, so now what I'm going to do, I'm going to just calculate this one with the positive, because I don't like to do something with negative. So I'm going to find this integral. So I'm going to say that the integral of 1 over pi from 0 to pi of t dt, I'm going to have 1 over pi t squared over 2 here from 0 to pi. And what is going to happen here? 1 over pi for t squared, that's going to give us pi squared over 2. For 0, it's going to become 0, and that is going to give me pi over 2. Okay, so that is for a naught. Okay, so now before I move to an and bn, I've mentioned that we're going to talk about odd function and even functions. So I'm going to start with the even functions. So since my function is terms of t, I'm going to illustrate using t. So if we say f of t is even, what does that mean? Okay, so it means f, I'm going to write even here to indicate that it's an even function. F of negative t, if your function is in terms of x, write this as x, is equal to f e of t. That means if you substitute the value of negative t and the value of positive t, it's going to be the same. That is what we call an even function. And if it's odd, I'm going to write O here for function f of t, and if your variable is x, you can just put x. So for this one, it's f odd of negative t is going to be negative f odd of t. Okay, you can see the difference. Okay, there are some people may say that a function is an even function if it is symmetrical along the y-axis. Okay, but some people may be confused about what does it mean to say it's symmetrical along the y-axis, so it's better to use this one. Okay, but as you can see, this one, the portion here and the portion here are the same, so it's symmetrical along the y-axis. That's what it means. Okay, if this portion was also under this line, that is going to be symmetrical along the x-axis. Okay, so what about this one? Is it an even or is it an odd function? Okay, we can see that f of negative t is also equal to f of t. So that means we can say this function is f of t is equal to mod t is an even function. Okay, so by just knowing this information, this will save you time in an examination. But instead of calculating an, bn, when you know the type of the graph you're dealing with, you can just say an equals to 0, bn equals to 0, and not equals to 0. Okay, so when a function is even, what does it mean? So when a function is even, it means that bn will be equal to 0. So that means we're not going to have n sign terms, right, for bn. And that means we're not going to calculate bn, we're only going to calculate an. And if it's odd, that means a0 and an will be equal to 0. I'm going to upload another video on odd functions. You have to watch it. Okay, so if you're liking this video or if you're benefiting, just click on the subscribe button. That's all I ask. And you can comment. If you have another question, I can reply to you as fast as I can. Okay, so now since we know that bn equals to 0, that means we are almost done. So now it's time we go to an. Okay, and for an, I'm going to write it here. An said it's 1 over L. So it's going to be 1 over pi for the first function, it's from negative pi to 0. And we're going to have ft. It's going to be negative t, but we're going to write cos. Okay, we have cos n pi t over L, and our L is pi in this case. And we're going to write dt plus 1 over pi for the second part. It's now from 0 to pi. We're going to have t cos, and it's n pi t over pi dt. Okay, and you can see our work have been made simple because we're going to cancel pi and pi. Okay, but as a mathematician or as someone who don't want to waste time, this is the graph of negative t and this is graph of positive t. I can just factor out negative v, and I'm going to see this graph and this graph will be the same. So instead of integrating by parts right here and also integrating by parts right here, I can just integrate by parts right here. And I know on this one I'm just going to put a negative outside. So that is what I'm going to do. Okay, so I'm going to integrate this one using integration by parts. The one with the negative, no, I'm going to choose the one with the positive sign, but I just like something with the positive numbers. Okay, so I'm going to say the integral of 1 over pi, the integral from 0 to pi. I'm going to have t cos, it's nt, the pi has been cancelled, dt. Okay, so now let's go to a level, or let's go to a level, right? Okay, so I'm going to integrate this by parts. So we know that the integral of uv is equals to uv minus the integral of v du dx, right? Okay, so now I'm going to choose my u. I want my u to be something that is to differentiate, and there's nothing is to differentiate in this case than t. So I'm going to choose t. That means if I say u prime or du dt, I'm going to get 1, right? And I'm going to say v prime, something that is to integrate. Since we've chosen t to differentiate, we now don't have any choice but to choose cos and t to integrate. And I'm going to integrate both sides to get v, since this is v prime, and we're going to get cos is now sine nt. And many people forget something here. When integrating, we have to divide by the derivative of the angle, and we're going to divide by n. So if you forget this n, that will affect your answer. Okay, and now it's time we write this one. For u v, my u is t, good. My v is sine nt for the angle over n minus the integral. I'm not going to put limits here, just not to confuse myself. So I'm going to write v. What is v? V is sine nt over n times du dx. This derivative is 1. I'm going to write dt. Okay. And here, what I can write is t sine nt divided by n. Let's just integrate this with respect to t, and we have to remember that n is constant. So I'm going to integrate sine. And if we integrate sine, we're going to get positive cos. We're going to get negative cos. I'm going to write minus negative cos nt, right, divided by n. But we have to divide by the derivative of the angle, and we're going to divide by 1 over n. And this will become t sine nt over n plus cos nt over n squared. Okay, and I haven't put my limits, so I know this is the derivative of this one. Okay, so now what am I going to do? Let's just make this a single fraction. So I'm going to write n squared as the denominator. N into n, we're going to get nt right here, sine nt. We're going to have plus cos nt. Okay, so this one, let me write it here. For f of ft equals to t, what do we have? We have nt sine nt plus cos nt divided by n squared. What about for ft is equals to negative t? We're just going to put a negative here and write what you've just written here. And I want to write nt sine nt plus cos nt divided by n squared. But there's something that I've forgotten. You can see we have a pi here. Okay, so we have to put 1 over pi right here and 1 over pi right here. Okay, let me just put brackets to indicate something. Okay, if you forget this 1 over pi, that will affect your answer. It's equals to the integral 1 over L, we said from negative L to L of ft, and say this one was equal to 1 over pi, negative pi to 0, negative t cos nt dt plus 1 over pi, 0 to pi, positive t cos nt dt. And we have integrated here and said that we have this what we have for positive t and for negative t. Okay, so we have nt sine nt over n squared pi. For this one, we're going to have plus cos nt on top. Okay, this one is the first for the negative, right? For the negative part, and you don't have to forget the negative that we said, plus nt sine nt plus cos nt divided by n squared pi. Okay, and for this one, we're not going to put a negative because that was for the positive t function. Okay, and we have to put our limits. We said for this one is from negative pi to 0. For this one is from 0 to pi. Okay, then to simplify our work, I have to tell you something. Okay, but some of you may already know it. We know that we have to start the graph of sine pi and cos pi. Okay, so I think we can agree that sine 0 is equal to 0 and sine pi is equals to 0. If we say sine 2 pi, let's just write sine 2 pi. We're going to get 0 again. So that means sine n pi will always give us 0. Okay, let's go to cos 0. If you say cos 0, we're going to get 1. Cos pi, we're going to get negative 1. Cos 2 pi, we're going to get positive 1. Cos 3 pi, we're going to get negative 1. So you're going to see that this one will oscillate around negative 1 and 1. But when n is even, we're going to get positive 1. When n is odd, we're going to get negative 1. So that means you can write cos n pi. Now if this value depends on n, it's going to be negative 1 to the power n. So when this one becomes positive, we're going to square. When this one becomes even, we're going to square a negative number and we're going to get a positive number. Okay, so what I'm going to do, I'm going to start by simplifying this and simplifying this. What if I want to simplify it together, I'll end up being confused. Okay, so for the first one, what I'm going to do, I'm going to have my negative right here and I'm going to put my mother bracket. Okay, so now let's agree. We have n here, we have t. If you put 0 here, sign will just go away. And I don't want to waste my time putting 0, because we all know that if you put 0 here, sign will go away. And if you put cos 0 here, we're going to get 1. You have to know that. So I'm going to, let me just put cos 0, right, over n squared pi. Now I'm going to say upper bound minus lower bound, right? Now I'm going to write minus, what is going to be the lower bound? You say that if you put sine n pi right here, sine n pi is equal to 0. Okay, just in case I didn't write it, let me write it here. Sine n pi, you've proven that sine n pi equals to 0. Sine 100 pi, sine 2 pi, that's going to give us 0. So if you put sine n pi, you're going to get 0, and everything will become 0. But it said cos n pi, so I'm going to have right here minus 0 for here plus cos n pi over n squared pi. And I'm going to write it. And what is going to be the answer? We're going to have 1 here. Since this one is the same denominator, just let us write them as the same denominator. We're going to have 1 minus cos n pi. We said it's negative 1 to the power n divided by n squared pi. And please don't say negative times negative and get a positive. This one is different from this one because this one is a power. Okay, so this is for the first part, right? And don't have to forget that we have this negative. If it is with this negative, we're going to have negative here. And if it is with this negative, we're going to have a positive here. So I can write this one as positive 1 plus 1. Okay, now let's move on to this. Okay, sine n pi. We're going to have n pi here. And that is equal to 0 plus cos n pi right here over n squared pi minus, let me just put the mother brackets, minus sine 0, that's going to give us 0, but we're going to have cos 0 here. So we have 0 plus cos 0 divided by n squared pi. Okay, and let's simplify here. Sine n pi, it's negative 1 to the power n divided by n squared pi. Minus, we're going to have 1 over n squared pi. Okay? Okay, this one for this one, this one for this one. Now it's time we add. Okay, so now you can write an is equal to negative 1 plus, okay, it's negative 1 plus negative 1 to the power n over n squared pi plus negative 1 to the power n minus, there's the same denominator, minus 1 over n squared pi. Okay, if we add this one and this one, we're going to get 2 of this one. So you can write this one is 2 of negative 1 to the power n minus 1 and minus 1. Why am I adding them together? They have the same denominator. So we're going to have minus 2 divided by n squared pi. Okay, and you can just factorize here. We're going to get 2 over n squared pi, right, of negative 1 to the power n minus 1. Okay, so the other thing that you have to check if I haven't made any mistake here, because one single mistake is going to ruin the whole thing. Okay, so now we have our bn, we have our an, and now it's time to write our Fourier series. And we have the formula. We have the formula right here. Okay. So let's write it. A naught. We have our A naught. We said our A naught is equal to 1 pi times this one. And we have said we have to multiply this by 2. Since we just calculated for this part. So I'm going to say this one times 2 and I'm going to have pi. Right? Okay. Just in case I had forgotten that. Okay. So now I'm going to say f of t is going to be equal to a naught. We said it's pi, so let us write it as pi over 2. Okay, plus this summation is n up from n equals to 1 up to infinity. For an, what do we have for an? We have 2 over n squared pi negative 1 n minus 1, and we're not going to forget that we're going to say cos n pi for t, okay, it's going to be cos, and I'm going to overwrite something, n pi, nt, and for L, our L is pi. Okay, for Bn, I'm going to have 0 here. Okay, I'm sorry for writing something on top of others, but I'm running out of space. Okay, and I'm going to have pi upon 2 plus n1 up to infinity, 2 over n squared pi negative 1 to the power n minus 1 cos, and this one is going to become cos nt, right? And let's just put the constant out of here. Going to have n over 2, and if you just put 2 over n squared, 2 over n squared out of the square root, we're going to have this summation from n equals to 1 up to infinity. We're going to have negative 1 to the power n minus 1 over pi cos nt, and that is going to be the answer. Okay, so thank you for watching, guys. So if you trace an error or if you see an error, just comment so that everyone can know, but this is the procedure. Thank you for watching.